Welcome back to another episode of a very basic space program. We're still in our once a week slot, and last episode we spent a lot of time with our Mars Pathfinder. Today we may have our arrival at Jupiter, but we also potentially are going to be launching our space station. So please join me. So yes, as I said in the introduction, we have a few things going on right now, and I'm not going for the moon. I'm not going to land some crew on the moon just yet because I see that as sort of one of our final steps, and I sometimes think a series sort of dies off when it gets to the moon or when it gets to Mars. Sometimes the two of those are the killers, and I want to do some other stuff actually with this series. I've landed on the moon before. Haven't done it with just generic sort of Russian engines or American engines or anything like that, but we'll get there at some point. I'd probably like to do something a bit bigger than just Apollo. I don't want to do just a recreation of the Apollo program. So what have we got today? We have potentially an arrival in Jupiter of Discovery 11, which interestingly is arriving, almost 200 days ahead of, less than 200 days, 180 days ahead of Discovery 10. So they're both going to Jupiter, so we're going to get some interesting stuff from them, hopefully. I think Discovery 10 will fly straight past, so we may have to do something with it on the way out, I'm not sure. We have this Earth-Saturn window, which we have a vessel ready for. It's actually just sat waiting. We can roll it out whenever we need. That's going to be in about what, 5 months, something like that. We've got Pathfinder going to Mars. That's going to arrive. We're going to probably take some contracts for that. I need to actually check. Do we have a? Yeah, we've got a Mars orbit contract we can take, and I think that's all we'd want. Yeah, we don't want to take the lander just yet or the probe. So that would give us a bunch of money as well. It doesn't need to be a new craft, so we can just do it when we sort of arrive in the sphere of influence or just before we get to the sphere of influence. We do need a pair. Now, that may be an issue. We do need a periaps below a certain height, and we're not going to have that. So we may actually hold off on that until Mars Pathfinder 2, because that's going to be a much closer vessel. However, potentially we also have the Phobos flyby that we could potentially go for. You don't need a new craft for that. So we could potentially play for that, or Deimos or something like that, so if we want to. The main reason for our Mars craft at the moment is actually science. It's science and communications is what we're really looking for with it. And just a bit of fun, see what happens. We're not doing too bad for funding. We are doing badly for science. We actually don't have any science being researched right now because we haven't actually spent our science points. We're just ahead of things. Hopefully the Jupiter mission, the Mars mission will bring in some more science, and we've got just general science coming in as well. Our first space station contract. Now this is the interesting one. Let's actually look at it. What's the requirement? This is the one I want to focus on maybe today. We've been doing the building work on these craft. So we need to put our station up. It's got to have space for at least 3 crew. I believe we have done that with it. I'll need to check that it actually has space for 3 crew. It will once we dock to it, I'm thinking. But anyway, reach orbit with a perigee of greater than 250, apogee less than that. So we're going to look about 300 kilometers orbit is what we're ideally looking for on that craft. And then we need to bring 2 crew to it. They need to spend 30 days there in that orbit. And then they need to go home. And then the station needs to stay in orbit once they've left in that same orbit for about 2 hours. And we get a big chunk of stuff there. We've already spent most of the money for it. So we probably need to do that. So I think let's start off this episode by launching the station and maybe doing that docking. And then we may get a little flyby of maybe Jupiter at the end. We'll see. We'll see how far we get. So I'm going to move forward until we can get Dawn launched. We're going to launch Dawn first. Then we're going to launch the Janus straight after it, and we're going to dock them as soon as possible. So, let's get that done. Now, I should point out that, yes, we have ruled out both craft onto 2 different pads. Main reason being, I want to actually have as short a time as possible between the launch of one and the docking of the other, because we're using fuel cells and things can eep away in time. So that's part of the reason I'm doing it. So we're going to go to Dawn, launch that, and then we'll bring the Janus up to match. Right, so we have wheeled the craft back in. One of the annoying things is you can't just remove a member of crew. You have to wheel the craft away. So we've wheeled the craft back into the VAB. We've pulled it back out. It's now standing really high. I don't think it was standing like that when we started. So obviously the wheeling in and wheeling out has moved its standing position, which is a little annoying because I really don't like it looking like this. But you know what? Things are as they are. we're going to get ready for launching this. So again, we're going to put it into the orbit of the moon. Oh, not in the orbit of the moon, in the plane of the moon. We're going to use this 2-stage, I'm going to call it a Saturn V. It's not, it's a Javelin 5. We're going to do that. Everything I think is ready. I think we are ready to go. That was an interesting little thing. So let us fire these engines and hope it works. Nice and loud to start with, and we have thrust and we are go. So yeah, that's an interesting one. I actually just repeated the same process I did the first time. We didn't get a person. I had actually checked that it was empty. I don't know where or how they got into the craft. I'm not even going to look at whose name it was because we're not going to penalise them for that. I don't really know how it happened. But it's an interesting one. It's a very interesting one. I may have gone a little early with this, but we'll see. We'll see how it goes. I often find if you use, one of the reasons I use the moon as a target is if you actually always launch into a relative inclination at the same sort of degree percentage, so 2.1 was when I launched. If you're doing a 2-vessel docking and they're the same vessel and launch profile, it actually really can potentially put you into a really nice alignment for them. That's not really the case with this because we've got very different launch vehicles, but we will see. We'll see what happens. This is a very long first burn on this engine and everything. We are coming over nicely. We're getting a bit of aero effect. I'm going to zoom right out so we don't get horrible noise because it is actually deafening me. I'm hoping I'm going to turn it down in post, and if I forget, please shout at me, tell me off for it. Yeah, we're coming over a bit now. I could probably turn a bit more actually. So again, we're going to aim for that 300 kilometer orbit. If we don't make it, we do have some thrust on the station, but I really want to save that. I want to save that just for, I was going to say station keeping, but orientation control primarily. It has about 300 meters per, well, 290 meters per second, which you can do a lot of on orbit with if need be. I'm actually too far now, am I? No, I'm all right. Right. So now we're going to keep going. I wasn't looking at the speed then. I was not looking at the relative speed, and that was not a good idea. In fact, you know what? I want to go steeper. So let's go at 35. And get a bit more altitude on this launch, because this second stage is actually not a long burner. This is what our standard sort of Javelin 4 burn time was sort of like. So, you know, I have to be aware of that. We're not getting as much thrust as I would have expected. Okay, we are getting up there though. That's good. So we're now going to be out of atmosphere, which is nice. It's always a good idea to be out of the atmosphere if you want to go into space, I suppose. And you can see our apoapsis is now increasing at pace. We can get a bit more speed on this stage actually. We're going to wait until it gets to about 250, then I'll probably level it out a bit. Yeah, we'll start leveling it out about now. There we go. You see our time to apoapsis is quite high actually. We will probably do a little boost off the station, but it's not a massive issue. We're above the required altitude. Our thrust is really high right now. And actually, in fact, our second stage thrust is quite high as well. And there we go. We can decouple that, start the engine up. There we go, single little engine there. Right click, yeah, it's got the RD0212 just working its way along. We can get rid of the fairings right now, and you can unveil the joy that is the station. So this thing must remember to make sure that we've actually turned on all of its sort of required bits and bobs. We've got an external ECLS, we've got that there, that's our converters. I must remember, where did I put the batteries? Are they there? There we are. So we need to actually make sure we're dumping that. And I'm actually going to turn the fuel cell on. We're going to do the same with this one. We're going to make sure the water is dumping, and then we're going to set it to run. And that should give us positive power right now. Yeah, we're starting to pull up power. That's good. Right. What I am going to do is actually pitch this down a bit. We've got a lot of delta V on this stage. A lot more than we actually probably need, in fact, looking at it. I'm actually going to pull it right down. There we go. Primarily because I want to get to that apoapsis time quicker. We're actually currently not going to be getting to apoapsis before our burn ends. So that's a problem. So we're actually going to do that, which is not efficient at all, by the way. Not efficient at all. But I'm looking at the delta V that we have available. This craft was overkill. The only reason I'm actually using it is because I could, because we already had it built, and it was the closest we pretty much had to a capable craft for this. So that's the reason we're doing it. And what I'll actually do is I'm actually going to try and keep that apoapsis pretty much not moving. It's going to go down a bit there. We'll pop it up to there. I'm not too worried about our times at the moment. I really would like it if we were not catching it, but yeah. So anywhere above 250 is good. Keeping an eye on our relative inclination. We're going to catch that soon. Got about 2 minutes 30 until we are pretty much on orbit. We're ahead of where I really wanted to be, which is annoying. So I think this craft, ideally what I should have done is actually take an engine off the first stage. Slowed that first stage down a little bit and put more onto this, because we have a lot of delta V on this. We have an awful lot of delta V on this. We've got 2 minutes more burn on it, and yeah, we could potentially just speed this up just a smidgen until we get closer to that relative inclination that I want. Getting the times down. We are not going to be pretty much where I want it, but we'll see. We're in the range. We're in the ballpark, and then this thing can do some of its boosting and things itself. Let's see, we now need to want to start thinking about our relative heading. So we're going to just move up a bit to about there. There we go. That's going to pull that back. Actually, go down a bit. Go down a bit. We want to keep bringing that down just to as small as possible. Yeah, we're actually getting to the point now where we are going to be going to orbit. Okay, that's good. At this stage here, we will, of course, get rid of this thing or do what it needs to do. Do a little thing here. I think that's going to be perfect for us. In fact, I want to point this down a bit more, like so, and then we're just going to kill that. There we go. Right, not the most perfect of launch profiles. We are a little bit out of what I would have liked, but we will deal with it. So decouple that, arm these things. We're going to put the RCS on. We're going to fire it a little bit away. Get it away, thank you. Superb. Right now, this thing I want to actually try and put into a circular orbit. So let's have a look. We zoomed all the way up because of the moon. We're gonna stop that. We don't need rendezvous planner at the moment. We get rid of that, and we're gonna actually unset that target. And we are going to just have a look and see where are we? Where am there we are. What I might do is what are we tagged as at the moment? What are we considered to be? Because it might be easier just to rename the thing. One of the things you can do is like a rename vessel. We want this to be a station. So we're going to put it as a station. And we're going to call it Dawn 1. Okay, there we go. Right, so now if I come back to map view, what I can actually do is I can turn everything else off. Get rid of everything else. Not those things. Definitely don't need the junk. I've just turned that on. There we go, and all we want to put on is the station. There we go, nice and easy, and we'll keep it like that because our next launch is going to be okay. All right, our apoapsis. So what we could do is we could go orbital prograde right now, and we can just bump our apoapsis up, and we can do that with either RCS or our little engines. We've got a couple of little sets of engines there which should run, and I may check that they are running. Let's give them a little fire. We're going to try and take this to. Actually, no, we're gonna raise our periaps first. Primarily because you can end up in a situation where you raise your apoaps and then you'd have to bring it back down again because of the slow burning of our engines. We've got 9 minutes of burn time on there, so we're going to warp to there. Oh, actually, let's not go to there. Let's go to here. Let's warp here. There we go. We're going to warp all the way around. The one thing I get the idea that the probe is out of fuel. You know what? I need to remember to actually set things to rubbish, basically. That's one of the things we need to do. This thing is rolling because it started doing thrusting and reorientating itself before. And you can see every time that we pause, it's actually trying to orientate itself to orbital prograde, which is a problem, actually. So there we go. We're going to come round and... Are we there? There we are, right. So we're going to go to prograde now, right. Put ourselves to prograde, and all we're going to do is just we've got about a minute. It's going to put itself on prograde. We're going to boost our periaps up just to be roughly circular orbit. It's just a little easier. There we go. We're going to get close to it, and we can fire it whenever we want. If we go off axis though, we will actually end up changing our inclination, which is what I'm trying to avoid. So then we're going to fire those engines. Because I'm doing it early, we're going to actually raise our periaps as well, our apoaps as well. So we're going to get that near to 300, which is, what we're aiming for. What we'll probably do is put our rendezvousing craft in a lower orbit, ideally, and have it chase. I can't remember how much fuel on board or life support it has. It's probably got about 24 hours, which isn't great, if I'm entirely honest, but you get worse. You can get a lot worse. There we go, we're coming in, and it would be really nice. Yeah, so we had a situation in the past where when you warp to node, it would actually warp directly onto the node. Now it actually takes you reasonably close to it, and then it does a bit of orientation change. And technically, we could actually have done this change with just the RCS ports. I didn't need to reorientate the craft, but we will do it anyway. So you can see we've got 280 meters per second left, so that's enough for some decent on-orbit maneuvers. We have, let's have a look, helium's running a bit out because we're using RCS. We've got the Mon 10 going, MMH is going, obviously the helium is there, but the pressure isn't. Let's have a look. What's our supply situation like while we're waiting to do this? Dawn, please. Right, let's have a look. We have supplies. Liquid hydrogen, about a year. Ooh, that's nice. Liquid oxygen, about a year. Okay, that's not bad. We are getting some solar power from this at the moment. Yeah, we go. It's dropping when the solar power drops, which is fine. That's not a problem. We could actually turn all of the fuel cells off and just run on solar power and turn off avionics and stuff as need be, if we so wished. So what I'm going to do is I'm going to warp to there. Okay, just move up to it. We are getting signal as well, which is nice. We're bouncing it off some of our relay systems and things like that, so that's a good thing. Right, we're going to just start that. Let's do a little thrust forward, I think. We shouldn't, in fact, let's use the RCS is a little bit weak, but let's do a little bit of thrusting, and then there we go. That's pretty much perfect. Right. So what I will actually do now on this is I will actually turn off. Where we go here, we're going to disable these engines because I don't want them firing by mistake, because they will send this craft into all manner of difficult situations. So we'll just, hello, thank you, give me that, shut down that. So that's our 4 engines turned off, you can see there. And then we're going to put this thing into the normal. We're going to let it rotate itself around into the normal, and we will do our docking using that sort of approach. So this has got 150 days currently of basically power. Lithium hydroxide's not going to be used up at the moment because we don't have anybody on board. What we can do is we could even turn our transmitter off if we could we could actually, we can activate avionics. That's interesting. Shut down avionics. Oh, activate avionics. Have I got an extra avion? I cannot remember building this. This is terrible. Did I have it all shut down originally? This is right, because this is designed 15 tons. Okay, so we have this avionics unit on the top there that we can actually, I believe it's a deep space one, so we can shut it down as we need it. So what we can do is actually, if we do that, you can see we go up quite a bit of time that we go up there. So, and I believe that will shut down as we time warp. Yeah, it will. So what we're going to do is we're going to jump back to the Space Center, and we're going to launch the docking craft. Right, so here we are on the launch pad. We have Regina and Annalise Mayer. We're going to send both of them up. We've got, so that's a pilot and engineer. Obviously, we need an engineer to make sure everything's working up on the station. How am I going to do this? Well, first of all, I'm actually going to set target of the moon. There we go, like we did before. We could set the station as the target, because the station is technically the target. However, I'd rather go for the moon because we know we were slightly short on the station, and we always go before the node and all sorts of things like that. So we can actually do it that way. You can go straight for the station and try and get to a 0 inclination. I just tend to find that I seem to do this, I don't want the rendezvous thing, I want a rendezvous planner. I tend to find that I just do better at the rendezvous in that regard. So in the past, and I'm going to bring up the alarm clock right now, because we're going to have, once we launch, we have about 1 day to dock, when that is limited by the oxygen on board the Janus. It's got about 1 day of oxygen. I don't know why I've only put 1 day of oxygen on it. I should really go back and change that and add a bit more oxygen. It seems a bit strange. It's got food and things like that for 3 days. I don't know if that's the way it's being calculated, or whether we're actually, I suppose we could probably generate oxygen from liquid oxygen. I don't know. I suppose I need a converter for that. It seems a little bit odd, but so what we will do is we'll be taking the Janus, try and dock it within a day, which means we have a limited window. So we need to really be launching at the right time. We also have this Jupiter window, this Jupiter arrival in 9 days. Now, of course, that's the arrival. its actual point where it's going to fly past Jupiter is going to be significantly after that. So once we hit that Jupiter window, we may jump across. We may not get this launch in before then. So this is the problem. So what we're doing is we're going to jump along to basically when we get our correct inclination or our launch inclination, and we're going to because what would actually help is if we actually turned on the pumps, because this is the one that doesn't. Yeah, we go. We've got electricity. That's one time that actually having that set up is okay. So you can see. Yeah, oh, come on, thank you. You can see that where are we? Our electric charge should be around here somewhere. I've lost it. It's vanished. It's magically vanished. Oh, there it is. It's now up to maximum. One of the big problems with this craft is I originally set it with one of these turned off because we're doing direct launch, and I keep forgetting to change the default setting. So you can see here we're actually just behind. If we were going to launch, this would be beautiful for us. We'd get a really nice close approach, but we're not actually at the point of launch yet. So that's going to be a problem. So we're going to have to probably go a bit longer. So there you go. In fact, we've got a long way to go. So what we're really looking for is for the station to be just in front of us so we can actually launch it behind it, or actually on top of us, because we will take time to actually get to orbit as well. We're completely out of water? How are we completely out of water? No, we have water. We actually have, wow, we've only got 1 unit of water. Now that's a concern. Interesting. We could end up killing the crew here by accident doing this time warpiness. Right, so we're going to continue. We're going to keep going forward, and this is pretty boring. Actually, we'll do a few cycles, and I'll show you about what I'm actually looking for. But yeah, production-based charges intermittent. So we're actually going slow because the production of electric charge is limited because we have fuel cells, I'm guessing. Right. Yeah, you can see we're really up here, not aligned, and we're out of water again. That's interesting. But it says we have water. That's odd. That's very odd. What I will do is actually get you to the next point, and then I'll probably show you, or I'll talk about it when we get there. So we are now ready to go for this one. I think we're just going to warp it forward just a little bit to get to our right window. And I think we're going to have to play it by ear a little bit, because I'm not sure if we're going to come in above or below. It's going to take us a while to get up, so we may actually end up being behind it. So we may go for a lower orbit. I think that's probably what we're going to, the best idea, go for a lower orbit and catch up. It could be almost a direct rendezvous, this. Right, so everything ready. Let's check. Oh, hello. What are you doing there? Get rid of that. Right, then that's the decoupler. Those and those to go. That's the code. Right, I think everything is ready. Get the engines going, get everything started, start everything. Let's go. Engines are go. Fire. Right, we are up. Now, I think we want to go into a lower orbit, so I'm going to aim for 150. We'll have to figure that out as we go, though. 200 would be fine as well. 200 would be an okay launch profile as well, so that's fine. We're just using those solids to get us going. Let's hope they decouple okay this time, because we have had problems in the past. I think the last time we launched anything like this, it was okay. I think since we've repositioned them, they are a little better. So we're going to bring this up, getting a bit of thrust there. That's nice. Our solids are pretty much spent now. So we're going to turn this over just a smidgen, like so. And then I'm going to get rid of the solids. There we go. Nice and easy. Gone. Right, we are on our way. And you can see this has got a slightly changed cone fairing over the top there. I believe Soyuz used something similar like this. It used to use a fairing over the top and whatnot. The Americans, of course, had their little escape systems on the top and everything, quite obvious to see. Apart from Gemini, which had the ejector seat approach, which there is a lot of debate as to whether it would have actually worked or not, or whether they'd have to have done it, or whether it would have killed them, or anything like that. So, yeah, I'm glad that we didn't have to use it, sort of thing. Right. We are heading on up there. We're going to keep an eye on this. So, yeah, it's going to go beyond us. So I think I'm glad that we actually didn't launch in the last window, because I think that would have been problematic. I think the previous window we would have been a long way behind. This way I think we're going to be behind, but not, sorry, long way. Yeah, we would have been even longer behind. We're going to be behind, but not by much. So that should be okay. Right. Down to 50-degree angle of attack. We're getting up there. It's definitely going, I mean, it's going it's going 7,000 meters per second. We're going 800. It's going to go past us. Let's be entirely honest on this. Right. Put it at 45, and then let's see. And there's a lot of flipping backwards and forwards, I know. So it's going to be there. Yeah. So we're gonna come in, and we're potentially gonna let it pass us, and then we're gonna catch up again. So that's not a problem. What I do want to do is actually start the process of just getting into orbit, though. Keeping an eye on that relative inclination. I think, yeah. Now, this is the interesting bit. You can see it is right above us. We could potentially go and meet it. I don't think that's going to be an option. I don't think that's going to be an option. We're going to have to come in below it. But our rendezvous could be within 2 orbits. It could be within 1 orbit even. It's going to be an interesting one. Right. Interesting little jump of sound there, I noticed, when you go between the map screen and this screen. It's very odd. It's been consistently in existence with Kerbal since I've played it, and it's an odd little glitch, and I'm not entirely. I wonder whether it's something to do with Unity. I'm not sure. Right. So we're going up. Our relative inclination is okay. Keeping an eye on that. I'm going to put this to 0. There we go. That's going to continue to climb, but that's not a problem. Oh, and we are out of the fuels, so we're going to fire our next stage. There we go. Right, and we can also... Oh, we turn on the RCS would be a good idea. Forgot to do that. Right, we can also get rid of that fairing. See, you can tell I've not launched one of these in a while because I've forgotten how to launch them. Right. It is now ahead of us, that's okay, and we're now trying to play catch up. We don't want our apoapsis to go too much higher. We can have it go higher, but we don't need it to. And what we're going to do is we're going to try and swing ourselves. Ideally, I don't know how far behind we want to be, because we need at least 1 orbit to catch it. 1.5. Okay, what are we looking like? We're not looking bad at all, actually, are we? We're not looking bad at all. At some point, we're going to put ourselves onto target 8. Yeah, we've got about 1 minute 40 until our apoapsis. Okay. I'm doing a lot of jumping around now. I realise I am doing that. I'm wondering whether we take this a little higher. Let's do a little prediction. Add manoeuvre. Oh no, I can't because I'm not targeting that. Get rid of that. If we were targeting this, we could actually do a little prediction as to where we could intercept it. My concern is that we're so close to it, it might actually fly past before we can do the manoeuvre. So I want to maybe pull us maybe a bit higher. So let's put us on 7 degrees. 7 degrees to give 8 degrees, 7 degrees to give myself a little bit of a push up. Just let that apoapsis go up just a smidgen, just get it going up. Because I don't think that distance is pretty that healthy right now. The difference in speed is significant, so that's going to take a little making up. So that's not a big concern for me. It's more about how long it takes us to catch and things like that, right? I think we need to focus on getting into orbit now. We are behind, which is fine. We may end up crossing in some really weird, odd way. I'm not entirely sure. That distance is growing. I don't mind it growing at the moment. Actually, it's maybe a positive that it's a little bigger. Of course, we do have to remember that we've got 17 hours till there, but I'd like this docking or this rendezvous to be pretty much underway by then. We're going to have to dock reasonably quickly because of the oxygen supply we have. Let's actually check. Where's our oxygen? Liquid oxygen, oxygen. Oxygen's hardly been used, so, you know, we've not been flying very long. Yeah. Turn this around the other way, so I like to see it this way. Let's have a look. We've got 3,000 meters per second. We could put a bit more altitude in. Let's put it up to 10. 15, just to slow us down. We are over a thrust away of 1.5 now, so that's not as big an issue. I'm just being aware of the burn time versus time to apoapsis. I'm just going to hover it around there now. Also, the closer we get to sort of 200 kilometers orbit, the less delta V we're going to need to actually do our rendezvous. So yeah, that's a point. We're now getting a lot closer to its speed. It's, you know, yeah. We're in fact, you know what? Let's do a right click on that holder. It's beautiful. It's in a 300 kilometer orbit. I'm quite happy about that. This is just going to take time, though. It's just going to take time, right? So our relative inclination is coming down. That's good. I cannot remember the exact relative inclination of the station, though. That's the problem. So yeah, I think it was like 0.28 or something. We will have to do some inclination change, which will be expensive. And I'm concerned. That's one of the reasons I'm concerned about delta V, actually. We may want to think about that. Let's have a look. Are we sat right underneath it yet? We're going to be, aren't we? We're going to be right underneath it, I think. Yeah. Okay. So what we could do is actually we can start zeroing that out a bit. There we go. That's better. Our time is now going... Okay, we're going to zero that. We're now at 200, so this is potentially close to a 200 kilometer orbit, which would be nice. I'd like a 200, maybe a little higher to get that rendezvous going on. I'm not entirely sure. Holding that relative inclination within, you know, 0.2 of a degree would be really nice. Be really good. We've got a little bit of burn time left on this stage, but we've also got... we're almost in orbit. I think we're pretty much good. I'm going to start preparing myself for what's coming next. So we've got like 30 seconds to orbit. We're going to pop the nose down just a smidgen, just to zero it a little bit. We want to get that time down just a smidgen, like so. And then I want to zero that again. There we go. Right. To there, yeah. And then to there. Right, and we're coming in, and there we go. Right, do that. Decouple everything. So RCS on. Are we decoupled? Decouple. There we go. Right. Now we've got to make sure our electric charge is set up. So we're going to dump water, run the cell. We've got to do this with all of them because it has this odd little glitch where it will not, it says it's dumping water, but it actually isn't. So that's a little annoyance. Dump that, get that. So we've got everything going. We do not want to do that because that is goodie bye-bye. It's the internal one of there, I believe, is it? Yeah. It is the decoupler inside here. Yeah. Right. So now we want to have a look and go, this is now our target. Hello? You won't close that. All right, we are in orbit, but why can't I target you? What is going on? What? Hello? Our stations are selected. Okay. That is the target I want. Let me target it. Right, I'm going to jump out of this and come back in. And we'll see. I'm going to have to reset a load of things as well. But I will jump back in and we'll have a look at what we're doing. Right, I've managed to set Dawn as a target, but it was a bit of a faff, actually. It really didn't want to do it. So let's have a look. If I do a prograde burn, do I get an intercept anywhere? There we go. We get an intercept there. That's intercept point. Right, let's have a look at what that's doing for us. Closest intercept is 700 kilometers. It's going up, it's going down. What if we do that way? Okay, then it loses it. And we're back, okay. Oh, we have a second intercept. Now, that is our problem, isn't it? That is a problem. That is, where are we? That's ours. That's target position at intercept. So they're ahead of us still there. Right, what about over here? That's our position, that's the target intercept. Okay, so what if we roll this on a cycle? Ah, better. Much better. What if we do this? Bit of this, bit of that. What if we move this around a bit? I think there is as close as we're going to get for that point there. Let's go for the second point. How close can we get? That's close-ish. That's not. Okay, so 15 kilometers is as close as we get. And then we have to do inclination. Okay. And then we're going to get to within 1.2K. Okay. A bit more of this. We're just playing around now. 800, 300, 140, 110. There we go. Right. So that's a maneuver in 1 hour, 40 minutes. It's 49 meters per second. That's a big burn for us, actually. What's our relative speed at intercept? Relative speed at 89. Oof. That is a little more aggressive than I would have liked, but like a minute burn. More than a minute burn. It's a minute and a half burn. I think we'll go with it. Okay. We'll just check all of our stuff is working. Do we actually have electricity being produced? We don't. We're using it. So when we've jumped out, and this is one of the big problems I find with these fuel cells, you can actually see there we go. Our usage of electricity's gone down because we've got one of the fuel cells working. Because you have to turn them on and off, which is rather annoying when you're having to load up craft multiple times and things like that. Right, so there we go. So now we're producing electricity again. Wonderful. Right, let's... now, it's going to be how much of a burn? We're going to have to do this manually, I think. So I'm going to have to warp around. If warp would work. Hello, warp. So that's interesting. So we've actually lost the ability to click on the top warp buttons there. That's another glitch occurring. So we've had our inability to actually... All right, that's the probe. That's okay. I'm actually going to turn that off. The probe is out of electricity. That's fine. We've no longer got the ability to put the speed up and slow down buttons. Okay, that's interesting. So we've had the difficulty clicking on the station and targeting it, and now we have problems with actually actually speeding up a time warping at all. That is interesting. This is this is definitely KSP RP-1 getting itself, showing you how to do things badly, I think. Right. Where's our note? So that's actually our burn point there. So, okay, and this is going to take, it says 48 seconds. I don't think it's going to be 48 seconds, but okay. We could actually have just positioned the craft and just done it. We could have actually done it with a manual burn, a control burn there. 8 minutes. We'll take it down to a little bit closer. Take it down to within 2 minutes, I think. There we go. Yeah, it's going to actually bring me in anyway. Okay. All right, let's have a look. We want to be on... I don't want to be on orbit. I want to, we want intercept actually. Let's put me on the node. There we go. See if we've got actually orientation control. Is this thing any good at orientating? It's not bad actually. It's not bad at all. It will be interesting to see how easy it is to dock this, because we have not really tested this design, have we? I think we did there we go. We did our docking maneuver. Yeah, that's this one. We did our docking with something else, so yeah, this will be interesting. 2 kilometers away at the moment, so we are actually close to it already. It's actually quite impressive how close we are. I didn't expect us to be as close as we actually are. I can't use that, so I'm going to do that. We're going to bring it into within about a minute. Burn time is that, okay. Right, and we'll do that. Slow down. There we go. Right, and this is the bit, and of course he always is on the dark side when you're doing all these rendezvous things. So yes, always the way. This is the bit that takes time. So this might be a short episode. It might be a long episode. Depends how long this takes. I really don't want to make the episode run too long. I've actually been recording for quite a while now already because of this, trying to get all these things. So I may cut some bits out. We will see. So let's see how this goes. 4 seconds, 3 seconds, 2 seconds. Let's start our engines a bit early, just because I can. I'm going to be keeping our eyes on these intercepts. That's going to be important to us. And we're going to be keeping our eyes on Delta V readouts. That's the two things we're really going to be looking at. This little engine design there. Somebody commented down below previously that this is a bit like, I think TKS and Almaz had that sort of concept of backwards facing docking ports and all that. And I can't think of anything else that does. So yeah, I think that those are the two. We've got an interesting offset thrust there. That's odd. Why are you firing? Why are you firing constantly that way? That is interesting. Have we got a problem with something being offset? One of our engines not being as good as it should be? Right, we are now at a point where I can do a bit of RCSing to finish this off, I guess. Within 20, 29, 28, you know what, do a bit more. Do a few bursts, because we can. There we go, and then we'll do a bit of RCS now. No, I don't want you to follow it. Turn. Prograde, just put it on prograde. That's what we're going to go for. Put me on prograde. That annoys me. That's one of the big issues I have, which is these things doing this, but we'll see. So we're just going to bring it in, do a little bit of manual maneuvering, a bit of that. No, I want a bit of that. You know what? That's close enough for now, isn't it? That's close enough. I'm going to turn that off. Right, let's have a look what our situation is. Electric charge is good. What are we doing for source of foods and whatnot? Still 1 day, 14 hours of oxygen. We're down to 95%. That's interesting, isn't it? So now I want to warp to here pretty much. Closest in 75, so we're going to warp to there. There we go. That's going to eat into... We're completely out of water, are we? I'm not entirely sure we are completely out of water, but we'll let that go. Pretty sure we've got water. I think that's coming back to the glitch that we've got. So I think the glitch that I actually have is... Aha. I think, yeah, we've got a little bit coming in. I think the glitch I've got is that we have a very large water tank. Sorry, a very small water tank. And that is the problem. So I think, note to self, get bigger water tank in future. I made it smaller just because I want to carry excess water, because the fuel cells, which this thing is going to run permanently, produce water. So we're just tapping water off. But I think the way the cycle works, if you're going too fast, it actually doesn't, the fuel cell takes a certain number of ticks before it puts water in. So you can end up with using all the water up in between a fuel cell tick when you're in time warp. So I think that's the problem. So what I would probably do in future is actually just increase the size of the water tank a little bit. How long until we're going to get there? We're going to get there in 6 minutes. I want to go target. I want to stop this actually. No, stop, thank you. I want to go T, and I want to go retrograde to target is actually what I want to do. Hold on a second. Do I not have a... Oh, you're kidding me. I don't have a control core on this, so I'm having to use the pilots, aren't I? Oh, now this is interesting because I like to come in normal, anti-normal. I suppose we could do a bit of a smart SAS on this. I could be a bit cheaty with it, but yeah, that's interesting actually. Can we do a little bit of refining of this? Can I get a bit of refinement on this? I can. Can I do a bit more like this? We can do a little bit of that. A little bit of that bring us in it. So we're actually going to be closer, I think, are we? Yeah, we are actually going to be a little bit. No, I want that way. No, I want to go that way. So we are actually going to be about 400 meters out. Okay. And this burn, let's actually figure. So I need to do, what's the burn going to be? The burn is going to be 89. So add maneuver. Well, can you just, I'm going to see how long an 89 burn is. It's about 1 minute and 30. About 1 minute and 30, minute and 20. Is it? Yeah, burn time 1 minute and 20. Okay, so we need to wait until we're about 1 minute and 20 out. Then we're going to start our burn. Actually, less than that. We need to be about 1 minute out, and then we'll start our burn, I think. So yeah, that's going to be what we're going for. Right, where is the actual target? Where are you? Where am I aiming for? We should be retrograde to the target, so I'm not entirely sure where it is. I don't see it yet. We did have it before. Is it coming from above? Is it coming? Is that it? No, I don't see it. Is it in the sun? It's somewhere, but I don't know where. So we're going to just turn this in. About 1 minute towards it, we will fire the engines, I think. Right, coming in, and right, we're going to be there now. So I need to, oh, there it is. I need to I need to start firing my engines pretty much now is what I need to do. There we go. And this is going to be a minute long burn, something like that. We're going to keep an eye on that. Okay, so we're actually getting closer by doing this. That's nice. I hope that's nice. 350 meters would be a nice distance to be away from this station, actually. And once we get within sort of stationary position, we will swap over the controls. Once we're just using RCS, we'll swap over the controls to target using the docking port. At the moment, we're actually firing our engines slightly towards the target, which is not what I prefer to do. I don't think it's realistic. But we will go with that. We will accept that situation. I would like to get closer. Oh, we got a bit of a glitch. It's a loading glitch because this is now loading up. Is it? Yeah, it must have loaded up. Right, 46 seconds away. We could actually afford to go a little closer, so I think we're going to. Let's get to 30 meters per second, and then we'll cut this and let us drift a little closer. There we go. And I might do a little bit of maneuvering just to get us closer as well, like so. We've got about 40 seconds to get there. We've got a load of delta V left. We should have enough to actually deorbit this craft, I hope. Actually, I haven't even thought about deorbiting requirements. Yeah, we have enough to deorbit it. That's not a big issue. All right, we're coming in now. We're going to fire again our engines, bring us down a little bit closer to the relative speed that we want. There we go. Slowing it down, 21 seconds to closest approach. We're going to be coming underneath it, which is not perfect because the station should actually be facing the other way around. 12 meters per second, 10 meters per second, 8, 7, 6, 5, 4, 3, 2, 1. There we go. We're going to be drifting closer now. So now we can actually apply a little bit of thrustage and just take ourselves towards that station is what we're trying to do now. Just going to try and let us drift in about, what's it say, about 9 minutes. We're going to get closer to it. That's okay. Do that. Take it up. That's within 60 meters, within 50 meters. 40 meters, 30 meters. I'm going to break all my normal rules here, and I'm actually going to allow myself to do this. I'm going to allow myself to. We can actually put it on target mode, can't we? Target negative, target relative velocities, relative velocity negative, and parallel. We could actually just use art and mech for this because when you're below 1 meter per second in the sort of stock control system, it will not let you do anything. So you have to be aware of that. So we're just going to, we got a time warp. Did you see the jump? Did you see the interesting little jump that we got there? So that's interesting. Yeah, you sometimes get that. There we go, within 100. Within 100 meters of the station, we're going to get a little glitch thing there. We're going to go within about 60 is what we're going to go. There we go. We could actually, are we going to go over the top of it? That's perfect. That's not my port, is it? No, it isn't. Right. So I want target relative velocity negative. That should pull us up into there. And then what we will do is we'll use the RCS to stop us. You can see we're almost actually at 1. So we could have actually used stock as well to not really standard controls. There we go. Oh, this is going to have a bit of a wobble, I think. Interesting. We do have a little wobble on it. All right. Now what we could do is actually target the docking port. Right. Are you... There we go. Don't double click on things. Sea monsters, that's a bad idea. Right, now we're going to do a little bit of... There we are. We're now pretty much at 0 to the target. And I want to control from here. And I want to go parallel minus. Right, now this is the fun bit, isn't it? I need to figure out which way we're going. That's that way. Okay, we can do that. Is it? Am I... Do I need to rotate you a bit? Is the problem. We're gonna position you... There we go, that's more pleasurable for me. Right, I want a bit of forward. Sorry, a bit that way. That's the way forward now. And then we want a bit that way. And then I really want to go towards it. So, like that. This is not as balanced as I would like. And my concern is it's because of this. These are not seemingly to do anything. Is this out of RCS or something? What are they using? I wish you could actually see what the engines were using. ISP28. Uh-oh. No, they are. They are the same. Okay. So, am I actually migrating sideways is the question. We are getting towards it. We are getting towards it. Are we above it now? Yeah, we are. So I need to do a bit of a thrust like that, yeah, just to stop us getting too far away. And then we need to do a little bit of time warpy. I think just do a little bit of time warp. There we go. And then do that again. Slow it down. And this is you know, this is just the way you end up doing it. Actually, I tend to find with the RP-1. There we go. There we go. So what I'm actually looking at now is the position of my prograde marker, the target, which is there, and me. So I know that I'm parallel. This is holding me parallel. So I know that I'm going to drift this way over time to here. So it's just about me basically hurrying it up a bit in reality. We're 24 meters away, and it's just about drifting it in now. It should go in quite nicely. And I'm just going to do that. I just want to pull it up just a little bit. And then we can do a little bit of timey-wimey warpy. There we go. And you can see now I need to bring my marker back. I need to bring this marker in because I'm going to be almost on top of it. There we go. That's it. And I want to go in a bit closer. How close are we? We can go a bit of forward thrust. And then we're just going to pull this to the other side now. There we go. We want our, basically what we're trying to do is line up our target, our velocity vector, and ourselves, so that we just slide on in there. Now I think we may miss this. Now I've said all that, we may have a slight move there to the side. We are coming in quite fast, to be fair. So we will see. We will see. This might be a bump and move. Oh, it's gonna be horrible. It's gonna be too much. There we go. Docked. Right. Turn off the RCS. Right. We are docked. Wonderful. Right. So I think with that, we're gonna leave that in orbit. What we will do first of all, though, before we do that, is we will do some crew transfer. So where is my crew? I want to transfer my crew. We're going to transfer you to here. Thank you very much. Is that possible? Hello? What's going on? There we go. They have transferred. Okay, wonderful. And now we're going to do that again. I've not heard that noise before. It's quite off-putting. Right. They're crumbling around and doing things. Obviously, we could have EVA'd them. They could have walked down here because we have actually lined up quite nicely. Could have gone down there and done that. Right. There you go. So they're now both in these little cans. This thing, we can turn off its avionics. Where are we? Shut down the avionics. What I also want to do is I want to shut off the food, water, oxygen, waste, the lithium hydroxide, the electric charge. We're going to leave all of that just as it is. We're going to basically store it as it is. And then I also want to shut off, we'll shut this off as well. There we go. Right. So they should be locked in. This should now be able to, if I do this, if we put on its RCS, there we go. It should be able to position itself now into the normal. And we should just now have to check that it has electricity and everything else. So it has, let's have a look. Where are we? Electric charge. It is losing electric charge currently. Okay. So do we need to check that the charge on these is actually working? Is this working for us? Let's check. That's working now, is it? Where's the electric? I keep losing the electric charge. There it is. So that's gone down a bit, has it? Possibly. What about this one? Dump the water, turn it back on. There we go. Okay, our electric charge is now going up. Right, okay. So we had one of those water dumping situations again where we had a problem dumping water, basically. And sometimes you do get that. But what we can do is we're running our pressure controller. Okay. Do we want to run our liquid oxygen to gaseous oxygen? I don't think we need to. Let's have a look. We have oxygen for days. We have water for 48 days. That's 48 days. So this thing is good to go. So let's check the mission before we leave it. We've got to remain in stable orbit now for 29 days. And then we've got to return the crew home. We have done all of the other things. So that's all we have to do now, is just let them sit. Now, the other thing is, we've got to, there we go, crew duration of 2 days. There's that we can actually do as well. So what we're going to do is I'm going to probably jump away from this. I don't know if the crew duration actually goes off as well. I'll have to have a look, because if we have a look on our little calendar-y thing here, we have arriving at Jupiter. We also have our Saturn departure in 68 days. So that Jupiter one is going to be the killer, because we're going to have to jump to and from it. So we're going to jump to that, start the next episode, deal with that, and then we'll come back to this, turn on all of its electric systems and everything like that, and hopefully we'll see it going. So from me, until next time, have a great one.